consists, the objective of this is to get the kinetic and the static coefficient of friction. So for that, we're using the help of our favorite physics teacher, Cimental. So let's suppose that Cimental is running late for his wedding anniversary. So first of all, we need to find his static coefficient. So 29 degrees.
Ha! That's correct!
No, it's a joke.
Now we have the free body diagram. Here we have the normal. This way we have the friction, that it's against the movement. Here we have the force in X, the force in Y. Here we have the weight. We have the angle of 29 degrees, the mass of 454 grams. Then we have to convert this to kilograms. And for the static coefficient, we're going to use this formula. This is equal to 0 because it's not going to move.
So we have that to get the friction force of the static movement. We need to calculate the static coefficient times the normal force. Now, how do we get the normal force? Well, according to this, since it's in an inclined plane, we are going to find the normal force by inputting the weight, that is equal to the mass times gravity. Okay, so weight cosine of 29 degrees. That is the equivalent of the normal force. We need to substitute the Fx, that is mg sine of 29, mg sine of 29, and then the force of friction is mg cosine of 29 times the static coefficient. That is, we need to multiply this times this, and this times this, and then we need to isolate the static coefficient, that is the multiplication of this, that is this, over this, and the answer must be...
Wow.
Let's suppose now Cimental is moving, okay? 1, 2, 3. Okay, now we need the acceleration of the system. For that, we're going to look first into the velocity of it. That gives us 7.791 meters over second. Now, this we divide over the time again to get the acceleration. That is our acceleration.
So now we're going to get the kinetic coefficient. For that we need the acceleration, that it's over here, and the formula we use for the static, but now it's going to be equalized to mass times acceleration because it will be moving. So now we input our values over here, we get these numbers for finally having the coefficient of 0.48.
So now, Cimental needs to get to his loved one, so right now our object number 2 is gonna be Tetra Pak Boeing of 250 milliliters. Right now, Cimental needs some motivation so he can get to his anniversary celebration. For that, we need to get the angle in which Cimental will start moving. And according to our calculations, that angle is a 31 degrees angle. So we're going to apply the same thing as the other object. We need to get our free body diagram, that is this one up here, and this is our sketch. Our mass is a 0.2288 kilograms, and we have an angle of 31 degrees. We're going to calculate the static coefficient. For that, we need to apply the same formula, and we need to substitute the same values according to the values of F in X, according to the weight, and in Y. The same, we need to isolate the static coefficient, and according to our calculations, our answer must be 0.601.
Okay, now let's see how much time does it take for Cimental to reach his loved one. 1, 2, 3.
So now we're going to take the kinetic coefficient. So now it's going to be equal to mass times acceleration. We change the angle to 32. We calculate the acceleration, that it's going to be of 0.109. And we put the numbers over here. We got these values. So the final kinetic coefficient is of 0.57.
And they lived happily ever after. Thanks for watching and subscribe.